Go to TAPgiles.com to learn dreams, engage my services, and support the channel. Cool, so now if I press circle, it does a forward roll. Let's have like stairs getting steeper and steeper. Let's see what that does. It seems a bit extreme that you can go all the way up there. Maybe it should just be on for shorter. Okay, so now it's working fine on the ground, and when you go up here, oh, but you could still do that, which is probably not great. So, now we get into vectors. So, imagine that's a vector, a direction. So, we're aiming that direction, but the stairs are kind of, the surface of the stairs are kind of pointing in that direction. So, like up here, they're pointing like that. So we, if we made a direction that is kind of perpendicular to that, so that it's actually the direction that we will be rolling in, then it would look something like that. So that would be like parallel to the stair itself, and as we go up, it's going to be like that, parallel to the stair and stuff. So it kind of reflects how steep it is. So if we had that, then we could say how much y is there? There's quite a bit, and there's less of the x. So like, let's do that. This is how much y there is, and this is how much x there is, and this is like the full amount, the full direction, but it has a smaller x and a bigger y for this direction, for like this stair going up there. And we want to ignore the y because we don't want to roll faster going uphill or whatever. So we just ignore that, and now we just have this shorter x amount. And this is how much like strength we want going in that direction. So we should roll slower when we're on this one because we're rolling at this speed instead of the full speed. So first we need to find this thing, but we already have the direction we want to move in, but now we need to get the direction of the stair itself. So if we get a laser scope, like that, and we point that down, I think it's just hitting itself. Stop hitting yourself. So if we put that, if we ignore, has this got a label yet? It's got friend. So yeah, just ignore friend. And then open this again. And now it's getting to the ground. And if I just like move it out like that, you can see it's got an arrow. If we go like that, it's got an arrow pointing perpendicular to the ground surface. And if we had one of these, and it hit that, then yeah, it's pointing, still pointing like in a perpendicular way to the stair. So now we're getting that arrow we had here, and we got that arrow which is the same direction as this mover, just the way it's facing. I'll put the mover over here and have 0 strength, and then it won't affect anything. But it will give us that arrow, because if you go here, it has the direction of movement, and that is that vector, that direction there. So cool. But now we want to like turn this into an arrow that goes across ways like that, across the stair, based on the direction of where we want to be heading. And for that we can do some complicated stuff that actually is easy with the gadgets but hard to understand. If If you imagine those just like that, then if we could get an arrow pointing 90 degrees to both of them, it would point like that, something like that. And then if we got a 90 degree between that and that, it would point like that. And then we'd ignore that. So you can see how between that one, this one and that one, there's like a 90 degree between those two, and a 90 degree between those two, and a 90 degree between those two, 90 degree between all of them. And then that would be the one we want, the one that's actually pointing parallel to the stair. So we want to do that whole thing. The process of getting the 90 degree between that and that is called the cross product between those two directions. And we have a cross product with a calculator over here. So if we wire the forward direction and the laser scope's hit surface orientation, which is that green arrow there, wire that in as well, put it into cross product like that, then that will get us that off to the side arrow, and then we just do it again with the hit surface orientation with the result of that, and that gives us the one perpendicular to the stair. So just as so you can visualize what's going on, what the result is. If we get a mover and stamp it onto a sculpt, then we can wire this direction into the mover's direction, and it shows us the arrow. So it's actually pointing downwards, so let's try doing that the other way. Now it's pointing upwards, yay! So that's the direction it would travel if we are rolling up it. And now we want to ignore the Y. So you can do that with a signal manipulator in custom remapper mode. So it has these are the parts of the wire. So this is a fat wire, which means it has like lots of values going through it, and that's what all those colors are about. If we put that into a splitter, we actually have 3 values representing X and Y and Z of the direction. And we want to have this affect the Y, the second value. So we want to bypass the X and the Z, and only the Y will be affected. And how will the Y be affected? It will be just reduced to 0. So it doesn't matter what the input is, the output will be 0. And then wire that into here. And now it's pointing forwards just fine, but it's if you want to see how the values are affected, this is it normally. So we've got some Y and some X, and if we like rotate this whole thing around like that, we have some Z. It all depends on what direction we're facing. But then we have this one which ignores the Y and only has the X or the X and the Z, depending on what direction we're facing. What's going on? Delete that. We need an advanced mover, so we can do all the axes separately, and then set these to 1. And then we can wire those into there. So it's moving perpendicular to the stairs direction. And if it was flat, it's hitting one of those. There we go. But if that was taken from ignoring the Y, then it would be going a lot slower as it gets steeper. Like that. So now we use that advanced mover. So actually we could just do that and not have that bit, because we're using a splitter anyway. And then set that to 0. Right, and now we just want that to be pointing down. So if we put that in the timeline again. Oh, is it? Because yeah, okay. So the mover, actually, you have this on local space, and it kind of thinks of this as in local space, and outputs it as if it was in local space. So this isn't changing direction, even when you're doing that, like local to the character, that isn't changing direction at all. And that's the whole point. So what we really need is like a world space version of that, and we can get that from a movement sensor with local space on, and it's got a Z, and it has these as directions, and these actually change depending on the direction you're facing. So you just wire that in instead, and now, yeah, the roll direction is changing as you look around. So if this is all like multiplied by 1 meter a second, so we can just, if we multiply the whole thing here, we can just do that once. So multiply by the speed we want, so maybe 5 meters a second. Okay. So maybe we want to roll further. Cool, and then rolling uphill is a lot harder because it doesn't like rolling, it ignores the up. So cool. What we can also do to help it is turn off the deceleration and acceleration stuff, because we want to just control the movement with this. So this is already turning off the procedural animation, and we can turn off the acceleration, deceleration, and air control probably. Nice controlled roll there, and going up the hill, going down the hill. Now going down the hill, it kind of doesn't like it because if this is up here, then the laser scope isn't hitting anything, so it doesn't know what direction to go in. So if it doesn't hit anything, then we should probably just have the basic mover setup. So basic mover, we can have that be the same speed as this, which is 5. Local space, pointing forward, and no damp in Y. Yeah, this should have no damp in Y either. Yeah, so this should be off unless this hits, so we'll just have a keyframe which turns that one on and that one off if this is hitting something. Yeah, so it looks like it's rolling okay, going down, but it's also hard to roll up the hill. Cool. Other problem that you might come up against is, as you saw when we were just playing about with it, this laser scope might hit like the edge of it or something like that, and then it should still work, but it'll be messed up a little bit. So if instead we had, as part of this group maybe, we have a sculpt, we could just use a wedge shape, and that represents the ramp, And the player won't be seeing any of this stuff anyway, because that will be invisible. And non-collidable, and if you do that, we can also make it low res, because it just needs the geometry, which will be fine for that. Okay, so now still walk up it, and you can still roll up it, so that the laser scope only finds the ramp and not these stairs, because that's the whole point. We'll give these a label of scenery and make this laser scope only care about scenery. So that should still work fine. And if you want to, you could make that invisible ramp collidable and make the stairs non-collidable. And then if you're having trouble with like actually walking up the stairs normally, then it's actually only caring about that ramp, and it'll be a lot smoother and easier for it to figure out. Thanks for watching. I hope you learned something interesting. Go to patreon.com/TAPgiles to learn something new every day.